Okay. So a while ago, and by a while ago I mean like last week, I started working, well, I finished this simple command line calculator in Haskell. And before you say, "Oh, no way, calculator," this is kind of like a stepping stone in a way, right? It's the first step of a big journey because I've been reading a lot into, well, I mean, just first of all, just generally, I've been very interested in programming language design, and I have these books. I mean, can't really see that. Like, okay, this one is not really that, like clean code, um, for clean code, but more importantly, this book that I have like read like 10 pages from, but in the first 10 pages, because first 15 pages actually, because like there's also introductory stuff. Um, it goes over kind of like the basics of how to parse a programming language, which I found quite interesting. Um, for example, you can see here, is that even visible? I don't know how visible that is, but like it shows like the kind of tree structure you need to like parse things. And anyway, it got me very interested in implementing programming languages because I'm already interested in programming language design in general. And I was like, you know what? It's about time I actually get to implementing one, to creating one, because I do have ideas for programming languages, but I want to like actually make something. So I've decided to start with a calculator, and I did in Haskell because functional programming is notoriously good for parsing stuff like that, just because of how convenient trees are and tagged unions are in these languages. I could have used like Raster or OCaml, spoiler alert. But those, like the way I wanted to structure this is to start with Haskell, right? A simple calculator, and then move on to OCaml, which I am currently working on, and then eventually, well, to make a more complicated calculator, and then to Rust for an actual programming language. Now, I don't know when I'll get around to finishing everything, but I can show you what I have so far just to start. Um, so if I actually go into my source code, you can see I have my four main files. Besides main, there's the parser, there's a tokenizer, and there's the evaluator. So main just goes ahead and imports all of these, and then yeah, just runs them using some funky control flow stuff. Don't worry about that too much. But the actual implementation, for example, of the parser, you can see I've got my um, uh, sorry, tokenizer first. The tokenizer is the first step. So you have my tokens here. You can see I got numbers, operators, and then parentheses as well. And then I've got my operators there. And then like just how clean that is, right? Like I don't know. I mean, I don't know how this would look in C++ because I haven't tried putting it in C++. I don't know if I will. I guess it'd be kind of like a fun little exercise at some point. But for now, um, I did Haskell, and you can see like it's pretty straightforward. You just kind of create a token tree. Which if I go to my README, you can see that I have it output each step of the way. Sorry, it's a list. So you get a list of tokens, and then you run that through the parser, which generates an abstract syntax tree, and then you run that through the evaluator, which folds everything into a single value because it's a calculator. So of course it will do that. Yeah. So the parser, here's the tree. Well, the tree is here. It's an an expression, because ultimately that's what the tree is in terms of a calculator. Um, yeah, you can see you got like the binary operators, unary operators, and then just numbers. And then of course, if they're like a binary operation of like adding, right? So you just add them together into one number, and that's kind of how it collapses, which happens with the evaluator. Yeah. I mean, I'm not going to go into crazy detail because I'm done with this. The reason I'm not taking this any further, like it has multiplication, addition, subtraction, and division, as well as parentheses, but that's it. There's no variables, there's no like special functions, and that's because Haskell is kind of a pain to work with. Now, although this looks very clean, I will say, if I wanted to add more complex features, it would just kind of be annoying. Partly because, like with adding variables, for instance, you kind of want to have a map of sorts, and that's kind of annoying um, without mutability. Um, and also, just like the more I want to kind of scale a Haskell project, the more the namespacing issues gets in the way. Like I have my token with with a T number, T operator, or like actually better example, operator to zoom in here with my plus, minus, asterisk, slash. But like if I want to access one of these operators, I don't do operator dot plus. It like plus is just in the global namespace. And that's so annoying. It means I need to basically prefix everything manually as if I were using C. And that is just like one of my biggest gripes with C. And then, of course, therefore Haskell. So I was like, you know what, fine. I'm not going to do everything in Haskell because I just can't be bothered to, and I don't see the point. Because, well, also because I want to learn a new language. Because I mean, I did some Haskell University and stuff, but a language I've been keen to try out is OCaml. Because OCaml is what Rust was first programmed in, from my understanding, and it gets quite a lot of talk. Now, I will say, just off, just to preface this, I have been a bit disappointed so far. But I'll go ahead and show you what I have. So I think it's in bin min.ml. Okay, so oh, that's right. So bin is where the main is. I sort of like have to like get used to this like whole build system, because it's a bit different from what I'm used to. Yeah, so you see here I've got my main, and then in my lib I've so far implemented and finished the tokenizer, which you can see here. It's I mean, if you're used to OCaml, maybe you find this not too difficult, but I definitely find this harder to read, and a lot like just less simple than I did find Haskell. But I'm used to Haskell, so maybe I just need to get more experienced. So what I'm going to do now is I just want to make some more progress. I want to finish implementing all of this stuff in OCaml, and then afterwards I'm going to continue to expand it. If well, I will try to expand it anyway. If I find that it is just way too difficult, um, then I want to push myself because I don't quit. That's right. So yeah, I have this obviously locally because I've been working on it. Yeah. Before I do that though, I just do want to actually kind of talk about some of these weirdness thingies. Um, what's my normal size? I think it's this. Anyway, so like with this, um, oh boy. Well, okay, so first of all, to import, we do open, um, because we're not really importing. We're more just it's like using namespace. Like that's what open does. Because in OCaml, if I have a library file like this in my lib folder, like you see here, got lib and bin, it's just imported automatically. Well, I say automatically. I think June manages it. Yeah, like you see here, like libraries calc. Um, calc comes from this, I think, because this is the name of the library, so it just imports it. And that uses like something like a Lisp thing. I have not used Lisp before, so this is all very new to me. Um, but it's interesting. And then instead of defining like a main function, you just kind of put all this stuff into an unnamed variable, I guess, like constant, like let empty parentheses equals, which is okay. And then we have our beloved match statement seen in Rust, which is match. This one does actually have namespacing, thank God. So we got tokenizer.tokenize, because that's the function from tokenizer. And then I want to tokenize this expression here. With is how it extends the options for the match. So you got OK and error, like the result type in Rust. If it's OK, then we do print end line, which is just a weird thing, but hey, it makes sense. And then in brackets, what I want to print. Now, this is my real issue, which is what the hell? If I want, so I think I can even show it here. In June, you can see I'm including the preprocess. I don't know the PPS. I don't know what to call this. It's like a module, like an external library, I guess. But it's necessary because I want to be able to print my token struct without having to define like everything manually. Because like in Haskell, you just do deriving show. and that is how it like, and then the rest is automatic. But in OCaml, you can't do that. So I need to like import this thing, and like I'm fine importing modules and stuff. But like, why is it so weird? Like percent sign show tokenizer t list, and then like I do that on tokens or something. Like I can't really like my eyes can't really parse what's actually happening. And like here, like I need to do double at driving show. Um, yeah, I don't know. It's just a bit strange. Although I will say my favorite thing so far about OCaml is that the comments use parentheses with a star. I think that's really cool, just because like parentheses are like how we do comments in a human writing, right? Anyway, also I feel a bit like people say that OCaml supports both functional and procedural programming, but I feel like that's a bit disingenuous. And maybe I just haven't like seen enough yet. But like from what I understand, the quote unquote procedural programming is no more procedural than like Haskell's do syntax. Um, but anyway, maybe I'll see more. So anyway, the tokenizer is finished. As you can see over here, I have support for all these different things, and now I need to go ahead and implement the parser, or the abstract syntax treeanizer. So I will of course be referring to my own code here. Um, yep, and let's get straight into it. So, oh yeah, also instead of like classes or like even like modules, like I have a module token which has this stuff because like, it's like a struct, but then like this stuff is also public. So like I'm kind of like, why is it called a module then? Very strange. In fact, when even what like when I swear I looked this up before, and OCaml was like 1996, which like is old, but like compare that to Haskell, which was 1990, and it's like, why is OCaml so weird? I just don't understand. But with time, hopefully it'll make more sense. So let's go ahead and create a parser.ml. OCaml uses the ML extension, um, which actually conflicts with like another language, which I think is also called ML, but whatever. I assume that's not an issue in the grand scheme of things. And how I do this, I'll create a module parser, I suppose, which is a struct, and we do need to use end for some reason. A bit of Lua there. And then we have our structs. So we have an expression, which is not data, but a type is what we call it. So type expression. I'll actually probably just write this out. Also, you don't capitalize it. Yeah. In fact, I mean, token. Yeah, I could make the module actually just expression instead. I guess that make more sense. Yeah, I'll do that. So module expression, and that's why this isn't capitalized. So I'll change this to exper within expression, and then we have different options. So we do equals, and then this straight away. We do include the spacing, sorry, and we have so a I mean the cool thing is that I don't need to like here you can see I'm prefixing everything with exp because again Haskell things are public, everything's just global namespace, but here I don't need to, so I can just do binary operation, so binary op, um, which I think, can I do this? Yeah, I do of, and then I think just same thing, so exper binary, ooh, expression, I'm guessing then. Binary op and expression? I don't know why it's red like that. It's actually quite weird. Um, would it be like this? Yeah. Oh, and bin op is a different thing, sorry. So this would be bin op. I believe everything uses snake case, regardless. So Yep. We also have unary operation of, well, just a unary unop, let's say, why not? And expression, by which I mean expr, and a number of double. I think double is what it uses. Or is it float? Float, my bad. A float, I think, is 64 bits in this language. So, yeah, sure. And then we just add the rest. So, for an expression, we actually would call this E. Or no, I think it has to be T. But I forget why it's T. But like, so like calling it T makes it default, like the default thing that you access. Again, is kind of confusing, but we'll just keep going until we get stuck. So I need to do double at deriving show, and then go ahead and include these other types. So we have a type for binary operator, uh, binary operator, yeah. Um, which, yeah, okay. I'll just put this here now, so don't forget. Equals, and we have add, subtract, multiply, divide. So add, yep, subtract, multiply, divide. In fact, I don't even need to do this. I can just do here. Add, subtract, multiply, and divide. I believe that's different from this because like these are like the symbols plus, minus, asterisk, slash, but these are the actual operations: add, subtract, multiply, divide, like the mathematical operations. Um, and then for unary operator, very similar, just one thing actually. I think it's literally just negative, yeah. So we'll just do this negative. Nice. I think that's actually it. We do need to import the tokenizer, but I think we're in the same library, so I don't think I need to even like open anything. Everything should be under the same namespace. I could open tokenizer, but I'm not going to do that. Yeah, cool. So I can't remember how I handled errors previously. So if I go back to my tokenizer, because I mean it has been a week, I will just say. So yeah, you don't specify the return type, which is kind of annoying, but whatever. So yeah, you can see here it can return either okay. Um, why is that the only okay? Because it's cursive. Oh boy. So with my Haskell, it was just right there and left there. Yeah. Yeah, because it's recursive. So it will, I think OCaml uses this syntax for list cons instead of just a single one, as Haskell does. So eventually it will reach the end of the input, and then it will just cons it onto an empty list, which makes the whole thing become a list, right? So that's why you have OK there, and then we have an error here. So the return type, I mean, the return type should be in like I forgot what OCaml calls it, but it should be in Haskell, it'd be either a string or a list of tokens. I mean, OCaml, I'm guessing it's like result type or something. But yeah, it's just weird how you can't see the function signature. Oh, you can see here I got result.map. So it is from the result thing. Um, yeah. Can I specify return type? Okay. So let's go ahead and ask my good tutor, Claude. Now, I do not use Claude to generate code, okay, for the record. I only use it to learn the language syntax and, well, yeah, because, I mean, yeah, this is a completely new language to me. So when it comes to, is it good practice to include type signatures, or like explicit type signatures? Or is that something people generally don't do? I only ask because I struggle to understand without them. Also, I mean, I know that like in like Haskell, everything's a function, but like this let syntax is really throwing me off. Like let tokenize input, so like it takes an input, so like it's a function, I guess. Like you kind of infer that. Like then why is it let? Like it's a statement. Like let f of x equals, I guess. Like I guess. I don't know. Like this language is just weird, you know. Um, yeah, it's just weird. In OCaml, explicit type annotations are optional but respected. So public API merge signatures always annotate. Okay, I don't have it below though. ML files comment and encouraged. Oh, okay, so I should do that. Right, but then like, it's, yeah. The thing is, like, you need to then put your things and your arguments in brackets, and like you have the final return type at the very end. It's really bizarre. It's really bizarre. I don't like it. I'm not gonna lie. But whatever, we will. So inputs, in this case, it is a string, which I guess is a lowercase or uppercase. It is lowercase. Interesting. I find it interesting that it's red. For the record, I do not have an LSP installed, like a proper LSP for anything, for my Neovim. So I kind of am just going a bit blind, but going in a bit blind. Yeah, and then it returns a result. No result. Is that how result works? God damn. It's a list. No. It's either a, oh my god. Um, OCaml result type. Okay, so it is lowercase results. Huh? Oh, but it comes after. Oh, that's weird. No, because I saw here like you have like token t list instead of list token dot t. Remind me, why does it have to be token dot t? Why t specifically? Because I do need to refresh from that. So in that case, I put it like in a tuple like this. So I have, is it A is the, I'm guessing the OK result. Yeah. So it's a token or a list of tokens. So a token dot t list, or there's a comma, right? Or an error, which is a string. Okay, I believe that should work. And then for inputs, here parse num. Yeah, this is also a string. And it returns a tuple, num remaining. So I'm guessing that'll be like a number, so probably a float and a string. I low-key forgot how you even compile this stuff. What do Claude say? The T is just convention or language requirement. OCaml modules are meant to be used qualified, so the idiom is the name property of a type module T, so it reads naturally. It's the same reason the. Okay, so this is actually used in the OCaml standard library. Okay. Right, so let's go ahead and duplicate this tab and remind myself how to compile. I think it uses June. Yep. So, was a June build? Did I even take notes on this? I should have taken notes on this. Nope. Okay. So let's go back to my notes here then. So how do I search? Close enough. That's ignore. How do I search inside my project? I am fairly new to not OCaml, Claude as well. Like I only started using it like about a month ago. Switching from Gemini because Gemini was just giving me aids. Um, June. Great. Again, fine. Oh, was it OPAM? No, it is June. Okay. Yeah, so it's just June build. It's a bit slow, but okay. Syntax error. Expression, yeah, because it's an E. I think I changed it right. Or T even. So this should be T, T, and T here as well. Is that it? Syntax error. The typing structure T expects 0 arguments, but here is applied to 1 argument. Right. So how does this work then? Do I need to like separate it by commas or what? I don't know why I'm just guessing. I can just check, but yeah, no. Okay. Um, first I'm just put this here. So build would be June build. And then was it June exec bin slash main.ml, I think. Well, no, because you want to run your project. So in my case, I had issues because if I did calc, it would literally run my calculator app, which was kind of funny. But I just do main.exe. Okay. So if I run the current one, because there should be one already. Oh, does it? It compiles when I try to do that as well. Okay, fine. Um, so OCaml tagged union. Okay. Why does it put me like in like the middle of some random place? Enumerated data types. Yeah, cool. Okay. Oh, you do times. Is that because it's a product type? Yeah. Okay. That actually. I mean, I won't say it makes sense, but like it's for considering it's called a product type. Is it a product type though? I thought it was a sum type. No. No, it's a product type. Okay. Sure. So let's go ahead and June exact this. Parsing error on line 18. Where? Okay. That's literally here. Why would there be a parsing error? I don't know. Syntax error. It expected something else? Is it not just a tuple? Okay. What is going on here? Yeah. Okay. Assuming this is even the correct signature, I mean, it says syntax error, so I assume it's a genuine syntax error. Um, but here, actually, this is before this. So, how do OCaml tuples work? And how do I return them from a function? Mm-hmm. Oh, is it times? Huh? Same star separated syntax as Haskell. Huh? Haskell has. Oh, these are comments. Haskell uses star syntax? I don't recall that. So does that mean that I need to put stars here instead? No way. What? So how would I, what's the word? Signify? No. How would I declare an explicit type? Does it actually use stars? Because that's like really points or inline. Yeah, why? It's literally a times. So it's treated like a product type. That is bizarre. But okay. So then I'm guessing same thing here. Okay. So what about in the results type? I saw it uses something like AE result. So is that just not a tuple? No. What the hell? Man, this is just so strange. I hope this makes more sense for people who've actually used OCaml, because like, what the hell? The value input has type string, but expression requested of type char list. Yikes. Oh boy. Okay, so it's not a string, it's a chart list. Um, yeah, I think I convert it here, string to sequence, because in OCaml, unlike Haskell, strings are not just lists of chars, because that's horribly inefficient. So I just need to remember what the thing is. I'm guessing it's input for starters. I think this would be char list, and then this would also be char list. Then. Wow. Yep, and then we can see our tokenizer at work. So it does indeed parse this thing from the beginning. 6.9 times negative in brackets 7/3 plus 2. That's the tokenizer there at work. So I'm glad I was able to declare the type signatures. That's quite useful. How about booleans actually? So C is a char. Is bool. It is. Yep. Like honestly, I just can't live with not having my type signatures. I hate that I need to put them in brackets like this, but whatever. I guess Lisp in general is just full of brackets. And I can see why Haskell wanted to move the type signature above, because goddamn. Right. So back to this then, our expression, um, or parser even. Okay, so we declare a new type for our parse results, which I believe you can do like this. So type parse results. Really strange that the types, by the way, aren't like they're also lowercase. Um, but also like, are they like this? Is okay. Well, that's a module, but the actual type itself is lowercase. Okay. Um. Ooh, but how do we store? How do we declare a type like this? Is it just the same as like normal? Like type this equals. I assume so. Um. Okay, so it's either a token list, right? Token list, or a string, because the string's error, that's correct. Result. That should be correct. I just realized, yeah, so this is a sum type. The product type is like a struct, because I guess it contains like different elements inside. I find it interesting then that like they do this for product types, but for the sum type they use like the pipe, like an or, as opposed to this syntax, which I guess would make more sense. Just an interesting thought there. Or like here they don't use like and. I don't know. Ugh, I did not invent this language. Yeah, let me just check that that compiles. I don't know why I'm doing exec. If I build, does it give me the same errors? It does. File none line one unbound module token. What? What? Do I need to move this up into the thing? How strange. So can I? Okay, let's ask Claude. How do I define a type? Oh wait, no. Actually, I saw an example here somewhere. Yeah, type point equals float times float. So that should actually just work. So let's go ahead and then do let declare our actual function. So it will be called parse. It will take in a list of tokens. So tokens, which is a token dot t list, and it returns a parse result. Okay, cool. And yeah, so for parsing, there are levels to it. The different levels are like different. What do you call it? Like ped mass, right? Or like bot mass, whatever you use. Um, because like the order of operations matters. Hold on. Okay. So what happens here? It parses L1 tokens. It's a bit hard to understand, to be honest. Like as compact functional programming languages are for this kind of thing, they're definitely not easy to understand at first glance. So like here, it's taking the results of parse L1 tokens, but L1 tokens itself goes to L2 tokens, and then L2 tokens itself goes to L3 tokens. So then these are actually computed first. Like the parentheses take priority over multiplication and division, which take priority over addition, right? Because like you want that to happen first. Like 5 times 3 plus 2 should be 5 times 3 first, 15 plus 2, 17. So yeah, it's quite interesting. Oh yeah. So yeah, parse L1, like I called it right, but it'd be like this because I'm using snake case. Parse L1, pass tokens to it, and then here I use a monadic bind operator. How bad? I forgot. I genuinely can't remember how I do that in this language. Did I even use it in my tokenizer? No, I just use token map. Okay. Okay. Ooh. Okay. Does OCaml have an equivalent to Haskell's what the hell, operator? Same operator. OCaml doesn't have a monad type class, so there's no universal this. Instead, each module defines its own button operator. Cool. The sign library uses let star button operator as the iterative approach. For option and results, open option or results. Okay. These modules define. Okay. Also, OCaml lets you also define operators. You can also use thing directly if you define or open it. How do I open it? Okay, yeah. So the idiomatic way is to do let star x equals m and f x. Okay. So then I would do like match x, I guess. Okay, so it'd be like, oh boy. Um, let I mean in this case I'm using the lambda case, so I don't need to give it a variable name, but I'll call it parsed, I guess. Naming conventions. So let parsed, and then what? Just do the thing that returns a result. Yeah, okay. So parse level 1 tokens in match parsed, right? And for match, I copy this with. Okay. Do I need to? I don't think I need to do this, do I? No, because that could an error. No, I didn't do this. Okay. So yeah, match parsed with, and then I guessing it'll be a tuple. No. Sorry, what does parse L1 return then? A parse result. Yeah, sorry, this is the wrong type signature. This returns either, again, successful would be an expression, so T, right? Okay, expression.t, or a string, and that's results. Okay, yeah. So not the parse result. That's for something else. Um, parse L1, which I'll just write out now to just kind of make this a bit more easy to process. For parse L1, that takes in a list of tokens again. So tokens token.TList, but this returns a parse result, as do the other ones. Okay, that's fine. So the parse result will either then be okay this or error this. So if it's okay, I mean, no, but this is now unwrapping it. Sorry. So did I do this wrong as well? Yeah, sorry. A parse result is either a string or a tuple. Bloody hell. It is getting late. So it's either what? Sorry. A tuple. Well, actually, I don't even. Yeah. Okay. I don't need. I don't even need the tuple syntax because I can just multiply them if that makes sense. So it'll be expression dot t or times a token list. I don't actually know if this even works. I probably need to wrap this, but let me not do it for now just to see if it works. I'll also see if this compiles. Unbound module token. Why is it? Oh. Oh, what? So do I need to open my own library? Um, That is weird. Do I need to open calc? Even though I'm literally in the calc module. Huh? Bro, what? This language is actually cooked, bro. Error module parser indirectory depends on calc. This doesn't make sense to me. Calc is the main module of the library and is the only module exposed inside the library. Consequently, it should be the one depending on all the other modules in the library. Bro, what is going on? What's going on? Did I like not define it in June or something? No. What the hell? Okay, Claude. If I have two different ML files in the same library, how do I import one into another? God, I can't spell. Bro. In OCaml files in the same library are automatically available. Yeah, I thought so. What? Well, I tried that. Oh, tokenizer token. Ah, bloody hell. My bad, bro. My bad. My bad. My bad. So it's tokenizer dot token. Okay. Now we should build. Yeah. Okay. That was a trip. So I mean, yeah, I can't really check this now because I need to define all the recursive things. But okay, so goddamn. So a tuple is defined. Yeah, I think I match it like this, just normally. So it's oh my god, expression or nothing, an empty list, and by or, yes, I write. Sorry, I'm a bit. It's like I kind of like watch my brain because in Haskell the left is the error, but in OCaml the left is the success. So this is successful if we have an empty list on the right side. So how do I match against an empty list? Is it like list.empty? I'm guessing. I will check this in a second. Um, you use the arrow. Oh, I probably use it here. It is actually just an empty list. What the hell? Why? Okay, so that's that then. And if it is, then just okay expert, yeah. And then if it is not, so I have something just wildcard here, and then the rest. Then I do return an error, which is could not parse tokens. And then somehow I need to have that join. Okay, the cons operator is this. String.make 1c. What? What's the right side? A string. If the right hand side is a string. No. It is. No. It's a token list. So I'll need to show the token list like I did here. Boom, 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 boom. Okay. Dude, this is so weird. But I think that should work. Can I build? Line 24. Where? Parser.ml. Line 24, characters, syntax error. Okay, I'm assuming that means it's good, because line 24 doesn't even exist yet. So I think this has worked. Okay, then we do level 1, which looks like I do T's for tokens. I don't feel like abbreviating it in this case. So kind of similar thing, just again let parsed equals parse L2. Tokens in nothing. Well, not nothing. Because then we call parse L1 rest. on tokens, on parsed even, right? And I can probably just do this then. So let's ask Claude here. So is this idiomatic? Let in chain. That bottoms out in a plain letter expression. What you have is fine syntactically if parse L1 is parse, it's a final expression, but the issue is scope, L star G sugars to bind, so you need to be inside a context where let star is defined. Yo, let star is actually kind of wacky though. Like, can we just talk about that? The more pressing issue is where does let star come from? Let open results. What? What? Yeah, I'm actually tweaking right now. Let. What is going on, bro? Oh. Okay. What the hell? God damn, this language is actually just difficult. Okay. Unbound module token. Again. Again. Tokenizer. Hilarious how it doesn't even, well, okay, whatever. So YW here, paste, okay, or not. Paste dot should be good now. Bro. Unbound value let. What do you mean unbound? What does that mean? Whatever your purchase of that is. Yeah, it is a result, but I can use result without needing to do that, no? Yes, seems like that isn't the issue. So I'm gonna go here. I wanna send Grok some more context because here I actually feel like it's kind of necessary. Uh, Clipboard. You should find let it somewhere as up to well. What? Why do I need to do that? Bug in your error message. This is missing the value you want. Oh yeah. Oh, okay. So it shows like a function. Bro. Thanks, I guess. Do I need to wrap that? No, I don't. Okay. For reference, parse calls parcel1, which is defined at that point. All right, they're order dependent. Ah, crap. So I need to like put this before. I hate languages that are order dependent. Like I love Rust because it's not. C++ suffers from like a similar issue. So I need to go ahead and add this here. And likewise, I need to put this above as well, which for some reason is messing up my formatting. What the actual hell? Okay. Sorry, I don't know why I put that there. That should be here. Did I do anything? I changed nothing. Okay, there we go. Okay. What? Giving a typical recursive descent parser, you almost certainly need. Oh my days. Huh, huh. This is a bit terrifying. Let's. What? So what did you let? Why is it? What? What are we doing, bro? Why is it doing that? Let's. Why? So many. Well, actually, one question. Why? Result.bind. Okay. Is this like a special syntax? Parser doesn't exist. Well, yeah. Um. Oh boy. Can you break down? Okay. This defines a binding operator, or OCaml lets you define custom let form operators by naming them let something. Just like you define a custom index operator with lets. Boom. Really? So why do I need to define it manually? That's really interesting. So that's like an operator. So why not just use? You can. It's preference. Let's say has more practical advantage. It looks like a normal let binding. Sure. Do notation. Really? Okay. Okay. You know that's interesting. So this whole let thing was made as an alternative to the Haskell do notation. Um. Yeah. Okay. I mean, I do prefer not having do notation. Um. I think that this is an interesting way to go about it. Okay, fine, fair enough. So that's it then. This works. I just need to go ahead and do the same thing. But like, man, I have to define this. Wait, hold on. I think it showed a different way. Yeah, here actually shows the order properly. Also, I forgot I need to mark things as recursive if they are recursive. Parse L1 might be recursive. I'm not entirely sure. I'm just gonna do this the way I think I should for now, and then if I can make it better later, I'll make it better later. So for rest, um, which takes in expression token. But what is that? I'm pattern matching it. Ah, boy. Oof. Okay, I'll close rest for now. And we'll have a type signature of expression as a tuple and tokenizer dot token dot list, right? And it returns the parse results. Um, can I pattern match directly? I can't remember. My tokenizer, I didn't. Let tokenize, I just did. I defined a go function. Um, oh, so then I guess I can just. Nah, so I still have to name it. Okay, sure. So go function. Can I do that? Or go equals function, sorry. Or just wait, do I even need go? Oh my god, man, I am dying. So function and then I just match. So like if it's well, we'll take a left and a tokenizer dot token dot operator or operator like this. Yep, operator dot plus in this case, right? I think that's how I do this. Obviously very verbose, but whatever. Um, cons. Okay. Cons onto. Why did I even put this in brackets? Was that even necessary? I don't know. Cons onto T's. Okay, for the rest of them, I guess tokens, and then parse L2. Okay, same thing as before. So it'd be let parsed equals parse L2 tokens in, and then I pattern match it. So it wouldn't be parsed. It'd be a tuple. Expression and rest. Then I call parse L1 rest. So this is actually recursive because it's calling itself there. With a tuple, it takes an expression and a list, right? So I guess I'll just pass this. Okay, so expression dot binary op. Is that okay? Then do I pass a tuple? So left op add expression dot binop dot add, and then expression there, like the rest of it. Then rest here. Dude, I am actually searching. Like I'm just in the dark right now. But okay, fine. This if it's not that, it'll be subtract for the minus operator. So if it's operator subtract, or is it minus? Minus. I mean, let me just check here. Yeah, minus. Okay. That would be binary up again. Just same thing, just subtract. And otherwise, we just return error. No, right to success. Okay, left tokens. So just okay it, I guess. Oh god damn, I can't wait for this error message. Quite merciful. Um, syntax error. What? Tokenizer.token. Is it not a token? So is it just tokenizer.operator? Did it save? Huh? Oh, it did save. Syntax error again. What? How I meant to do it? Do you just how do I do it here? Token dot print is open. Okay, how about like plus minus and all that? Oh. No. No. Yes. What? It's just open scope. So is it just tokenizer dot minus? Is that it? Okay. That is it. That is bizarre. So then in that case, I don't even need this. I can just do this. Well, no, because I assume I seem to have that. But But it's actually no, because it's part of the binary operator. So I guess I don't even need to qualify that because they can like infer what the namespace is in that case. Um, the entire thing. Thanks. This expression is type A to B, but an expression was expressed of type uh, parse result. Or what is A to B? That's like the least useful. It has type A to B. Like I gave it a type here, did I not? Parse results, yeah. Also, what does function even do? Let me just change this to a match for now. Um, because I don't actually know what I'm doing here. Okay. So this should be an expression dot t. Tokenizer token dot list. Where's that? Man, what the hell? Okay. 21, tokenizer dot plus. Didn't like that apparently. Unbound constructor tokenizer dot plus. Like it doesn't exist? Because I just tried to do it without that. I see you have to do token dot plus, surely. Just without the operator. Belongs to the variant type calc tokenizer token operator, but the constructor was expected belonging to the variant type token dot t. Is that so? Yes. No. What? T operator plus. Okay, sorry. So this takes a dot token dot operator plus. Why? Because here I have operator of operator, so I'm passing the operator into the operator. Oh my god, this is hard to even like talk about. I think that should be correct. Yep. Unbound value. Okay. So I need to, of course, define parse L2 tokens. Sorry, parse L2, just full stop. So, oh boy, let's do that then. Pretty much same thing, just change this to 3 and change this to a 2. I believe that's all there is to it. Otherwise, it's exactly the same. And then copy this as well. Right. And just change this to L2 rest instead. And change some of these things. So instead of operator plus, we have operator asterisk. And then here be slash, I think. Yep. And then for asterisk, you want to multiply, of course. And for this, you want to divide. And that should pretty much be the only difference. Make sure. Sorry, is it parse L2 or parse L3 here? Because here I put parse L1 rest, but actually that should probably be. No, this is parse L2. That's right. So this is parse L3. Am I tripping? This should be this. Okay. Yes. Okay. 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 Build parse L3, unbound value. So yet again, we'll just go ahead and copy this. And this would be parse L3 rest now. L3 is a bit more complicated, but yeah. In fact, there is no parse L3 rest. It's just parse L3. Okay. Boy. Okay, so parse L3 is the same type signature as the other ones, except we're pattern matching directly. So how do I do this? Match tokens with, right? So T parenthesis open. Here I have parenthesis open. So I'll do tokenizer dot token dot parent. Well, actually, can I actually get autocomplete? I can get autocomplete. Thank you. Const onto tokens, or T's we'll call it here. Yeah. Equals, or there's an arrow would be here. Parse L1 T's. Oh my god, this again. Sorry, let star expression and rest equals parse L1 T's in how's it getting? Oh, because tokens from here. Okay, that's fine. Rest isn't actually no, it's used here as well. Uh, I should really rephrase this or like rename this. Let's call these inputs instead. Because it's a bit confusing otherwise. Okay. Yeah. So it's open case. Then we do another match. No. Yes. Yes. So in match rest with um tokenizer dot token dot parentheses close onto rest like that. Then it's being okay. Expression rest. For everything else, we just error. Missing closing parentheses. Because what it does is it checks for well, it will wait until it finds a closing parentheses, and if it doesn't, then we know there's an error. So missing. Okay. And it'll be parenthesis, I think, right? Because it's a singular. Yeah, that should. I mean, it's the idea is there. I don't know if this is even correct, but let's go ahead and add the rest here. So we also got tokenizer dot token dot typo there. T operator minus, so token like this then, operator minus. Yeah, yeah, it must be. Again, const on t's. Then similar thing. We take the, again, expression and rest, and we simply return okay. Expression dot unary op, is it? Yeah, unary op negative. Expression. And then rest. Okay. That one's a bit easier, a bit more simple, I should say. For a number, we don't even need to like unwrap it or anything. So token operator. And yeah, it should be a number. N, let's say, or yeah. For that, we just return okay. Expression dot number, right? N and just tease. Fair enough. And then the other two are errors. So get empty list, which would just be an error, unexpected end of expression, and the unexpected token. Unexpected token, which is this like whatever string add. Same thing as before with the show stuff. Show tokenizer dot token dot t t, I think. List, okay. I need to have my colon. Okay, this looks correct. Let's get to the errors then. Expected. Okay, line 27. In parts L3. What? That's not L3. Oh, it's here. Okay. Expr. What's wrong? Syntax error, expected closing brace. Is that because it needs to be a tuple? I can only assume that's the case. Because it seems like any type that is a product type is characterized by a tuple, which would be interesting. So, is that correct? Okay. I will say I like how I can make assumptions and they turn out to be correct. Or at least I assume it's correct because it's no longer giving me an error. Although I don't know how I feel about like that's not really easy to read either. Man, this is tough. This is tough. Syntax error. Mm-hmm. I've got to actually unwrap this. So for minus, sorry, I need to first parse L3 of what? T's in this expression. Parse L3. Line 22, unbound value, parse L1. Yeah. Okay, so this is okay, so in this case, kind of what Claude was saying with the and syntax. Um, here parse L1 tokens and parse L2 tokens and parse L1 rest tokens. Yeah. This is gonna be rough. Really rough. Um, mm, okay, first of all, are they all recursive? That's the real question. I believe they are. Because here this calls L2, which calls L3, and eventually it can call L1 again from L3. So I don't know if that makes a difference. No. Um, yeah, okay. It's times like these when I will actually literally ask Claude. So, because in this case, I just don't know what to do. Um, so let's see how it handles this. So the parser. Okay. So I've tried defining my functions here, but seems I have an issue since parse L3 calls parse L1, but parse L1 indirectly calls parse L3, which works fine in Haskell, but OCaml has a different setup. It would seem. It's going to read the file. Hope you're liking the angle, by the way. It's kind of the only way I could get some like decent lighting on my face. The fix straightforward, make all the mutually recursive functions part of one. Let's rec and group. Seen once before. That's funny. Huh? Oh, right, individual. Okay, so if you have a rec at the recursive at the beginning, then it will make all the rest recursive. Okay, shouldn't be too difficult then, or too complicated. What's wrong? This? Oh, right, okay, it's not a token list. Oh, yeah. Okay, so let's go ahead and so do I start with parse L3? I do. Okay, so recursive, and then just like and like literally just like this. Oh my god, this is so messy. Um, bro, why is it? Why is my syntax highlighter actually tweaking? Okay, remove the recurse keyword there, and parse is parse okay by itself? I think it is actually. Let's have a look. Gene build, line 33. Is that our first one? Yeah. What's wrong? Syntax error. Is it not and let? It is not and let. It's just and. Okay then. Boom, bam, ba, ba, da, ba. Yeah, that should fix that. Redundant case. This match case is unused. What do you mean unused? It's a warning. Okay, does that mean I can execute it already? Error. No. They're actually errors. Okay. What the hell? This case is unused. This matches case unused. What do you mean unused? And I get a non-exhaustive error as well. Huh. Is it non-exhaustive? It shouldn't be. Unless I've defined something incorrectly. So it says at 26 and 29 and 31. Oh, are not used. And 30. Okay, so literally all of these except for this aren't used. What? What? Here's an example of a case that's not matched. Um, why does t constant to nothing not cover all the other cases? Because I've got empty list and t constant to nothing. So that should cover everything now. Because it just covers every arbitrary token. Am I tripping? Literally, what's going on here? Like, why is this not correct? Um, is it because I'm not using like? Do I need to use brackets? No. Seems to be the same. Hmm. I like that it gives an example, I guess. I'm so confused here. Yeah, I don't know. Let's okay. Let's what's the word? Inquisit inquisitive about this. So how come I get what's the error? Redundant case errors. Like these seem exhaustive, no? The inner matches shall swallowing the outer one. Okay, I thought so, but like why? The bum in the inner match catches everything, making the match redundant. Fix it by wrapping the inner match in parens or begin end. Oh, Shiza. Oh, it thinks this is going on. Ah, for God's sake. Yo. So it thinks this is going until that. Yikes. I thought, yeah, because like in Haskell, the indentation matters, but I guess in this language it doesn't. How does that look with begin end? Begin match. Okay. I will opt to use begin end. I think that looks a bit cleaner. I like how it goes red. Like I'm not using an LSP, so just a highlighter or whatever. Anyway, so that's why that made no bloody sense. Let's see if it shows up anywhere else. No way it compiles. Are you joking? Are you dead ass? This actually works? Okay, if this actually works, I deserve the biggest pat on the back because what the hell? So let's go and implement this then. So we match a tokenizer, tokenize. If it's an error, it does that. If it's not an error, then we want to print this. And then I think I need to use the semicolon operator there. And then I want to do the same thing. So match parser? Loki, what's it even called? Like, why is it called tokenizer? Okay, that's not helping. Is it called tokenizer because the file's called tokenizer? Must be. So parser dot parse tokens. We're gonna begin match. So I can end it. Not making the same mistake again. With okay. So again, if it's okay, then we have our abstract syntax tree, and we want to print uh, parser dot expression dot t, right, on our abstract, just AST, just call it AST. Yep, that should work. And if it's an error, then just go ahead and print that. Okay. I'll be very surprised if this actually works. Wow. Yeah. Wow. Okay. Bloody hell. Let's go ahead and just print an end line here. I don't even know if I need to. What's wrong? This first print end line has type string to unit. It's fired too many arguments. What? Too many arguments. Does it want 0? Oh, because I need a semicolon. Yep. Okay, I'm learning. I'm learning. So let's compare this to my thing here. Here I have the list, right? 6.9 asterisk minus like that. That's really correct. So for this one, and for the tree, I should have a binary operator. In fact, let's just look at the actual let's just look at the actual input because that'd be a bit more informative. So we should have 6.9. Yeah. So we got binary operator. In this case, I'm not using Polish notation, so I've got the operator in the middle. A bit confusing, but it's fine. And it stores them as a tuple, whereas in Haskell it stores it just as like this, like 1, 2, then the other thing. It takes me getting used to. So 6.9 multiplied by the unary operator of so the binary operator constitutes of 6.9 times and then a unary operator, so that's in brackets, because as you can see we've got this in negatives. So the negative is here, and then the negative contains brackets for the binary operation of should be what would it be in this case? Division or multiplication first? Division in brackets, and then add that, yeah. So we've got division where we have 7 and 3 as numbers being divided, and then that as a whole is being added to the number 2. Cool. So against all odds, this actually works. Oh my god. Honestly. Honestly, I am just as shocked. Well, I don't know. But I'm quite amazed that actually worked. What the hell did I just write? Like, I don't even understand what I just wrote, bro. I mean, I do, but like, it's just so. Ugh, ugh. Okay, there's probably a better way to format this as well. But okay, just like that, I have finished my parser, and I can generate an abstract syntax tree, which means the only thing left to do, besides what's the word? Besides refactoring my code, is to evaluate, which honestly is going to be really easy to do. Granted, I don't face issues with like this stuff. Like, cause I mean, in Haskell, it's really simple. Like, you just map, you f map, function map. Like, this is really simple. So you just add it and then you wrap it in right. I don't know how straightforward that'll be in OCaml, but anyway, I think I'm done for the night. I'm just going to go ahead and commit this. So git add, git commit, finish parser, and let's push. Awesome. And then I need to actually make a README for this at some point, but it's fine. Cool. So in my lib, I've got my parser. Awesome. And I've got my bin. Cool. So yeah, there we go. That was surprisingly straightforward. Obviously, like I am copying a lot from my Haskell, so that helps me a lot with not getting stuck. But even so, like yeah, obviously I had to use Claude to help me with quite a bit, but ultimately it kind of just worked, which is surprising. Um, and while of course you could mean that then OCaml is a logical language that's very easy to use, um, I would not say this is easy to read. So again, I'll come back to this and see what I can do to refactor it. But I'll do that after I finish the evaluator. So yeah, if you watched this far, thanks for watching. Um, this took about an hour and a half. Not too bad. I do feel like I understand OCaml just a bit more now. And I'll be back to finish this off later. Yep. Adore. I can't end like that. Arrivederci.